Have you ever looked up at the sky and wondered what are the ultimate war machines dominating that vast space? What is the pinnacle of military aviation technology? The true beasts capable of shaping the global balance of power. In a constantly changing world where technology evolves daily, air power remains a crucial factor, affirming a nation's standing. Today, we will embark on a special flight together, unveil the secrets, and explore the top 10 most powerful, most formidable military aircraft on the planet as of today. This isn't just a simple list. We will take you deep into the heart of each aircraft, from legends proven over time to the stealthy super creations of the future. We will analyze everything from groundbreaking stealth designs, cutting-edge avionics and radar systems, to the devastating weapons they carry. Who is the true king of the skies? Which aircraft possesses the most fearsome multi-role capability? And who are the strategic ghosts that can silently change the battlefield's outcome? Specifically, we will offer objective assessments, insightful personal opinions, and even fascinating predictions about their sky-high price tags. Are you ready? Let's begin our thrilling journey, exploring from the 10th position and gradually advancing to the champion, the aircraft hailed as the most powerful in the world. Don't take your eyes off the screen, because what you are about to witness will exceed your imagination. The flight exploring the pinnacle of air power is cleared for takeoff. Starting our journey at number 10 is a name that has become legendary, an unmistakable symbol of U.S. strategic air power, the Northrop Grumman B-2 Spirit. Born during the Cold War with the mission to penetrate deep into enemy territory and deliver nuclear or conventional strikes without being detected, the B-2 redefined the concept of the stealth bomber. With its unique flying wing design, lacking traditional vertical or horizontal tails, combined with a skin made of composite materials and coated with advanced radar-absorbent paint, the B-2 was built with one ultimate goal: stealth. It significantly reduces radar, infrared, acoustic, and even visual signatures, making its detection and tracking extremely difficult for the most sophisticated air defense systems. Not only stealthy, the B-2 also possesses an impressive range, exceeding 11,000 km without refueling, and can fly anywhere in the world with just one aerial refueling. Its large weapons bay can carry up to 18 tons of bombs, including strategic nuclear weapons like the B-61 and B-83, as well as conventional bombs, GPS-guided bombs like JDAMs, or even the GBU-57 MOP Massive Ordnance Penetrator Super Bunker Buster. This allows the B-2 to conduct precision strikes against high-value, heavily defended targets deep within enemy territory. Objectively assessing, the B-22's greatest and undeniable advantages are its stealth capability and strategic range, which were nearly unparalleled at the time of its introduction and for many years after. It proved its capabilities in actual campaigns in Kosovo, Afghanistan, Iraq, and Libya. However, its fatal flaw is its cost. The B-2 was one of the most expensive aircraft programs in history, with enormous development and production costs, leading to a very limited production run. Only 21 were built, 20 remain operational today. Its operating and maintenance costs per flight hour are also sky-high, requiring specialized infrastructure and technical teams. In my personal opinion, although it has served for decades and its successor, the B-21 Raider, is emerging, the B-2 Spirit remains a formidable and somewhat frightening testament to America's first strike capability and strategic deterrence. Its distinctive silhouette gliding through the sky still carries enough deterrent power, a reminder of its global reach and potential destructive force. It is a legacy of an era of confrontation, but remains relevant in today's complex geopolitical landscape. Speaking of price, predicting the price of a B-2 is nearly impossible, as it was never sold on the open market and production ceased long ago. However, to grasp its expense, the total program cost was estimated at around $44 billion USD in 1990s dollars, and the cost per aircraft, including allocated research and development, was often estimated by defense sources to exceed $2 billion USD. Its operating cost per flight hour is also considered extremely high, reaching hundreds of thousands of dollars. It truly is a precious and extremely expensive jewel of the United States Air Force. Moving up to number 9, we meet a name both familiar and new: the Boeing F-15X, Eagle II. This isn't an entirely new design, but a spectacular makeover of the legendary F-15 Eagle lineage, a veteran warrior that has dominated the skies for decades, now reborn with the power and technology of the 20th century. What makes the F-15X special and earns it this spot is its massive weapon payload capacity, among the highest for fighters today. It can carry nearly 13.6 tons, 30,000 lbs of ordnance on 12 air-to-air and 15 air-to-ground hardpoints, including up to 12 air-to-air missiles, or a diverse mix of air-to-air and air-to-ground weapons, potentially even hypersonic weapons in the future. It's no surprise it earned the nickname Missile Truck or Flying Arsenal. Not only powerful in firepower, the F-15X is equipped with the most advanced avionics. The cockpit is fully digital, with large area displays LAD. Digital fly-by-wire flight controls optimize maneuverability. Most importantly, it features the extremely powerful and APG-82 Active Electronically Scanned Array, AESA Radar, and the Eagle Passive Active Warning and Survivability System, EPAS, a sophisticated electronic brain that helps the F-15X detect threats, protect itself, and effectively respond in complex electronic warfare environments. Its Open Mission Systems, OMS architecture, also allows for easy integration of future software and hardware upgrades. Objectively assessing, the clear advantages of the F-15X are its unmatched firepower in the fighter class, long range, impressive Mach 2.5 speed, and an airframe proven for durability with a design life of 20,000 flight hours. Its acquisition and operating costs per flight hour are also considered significantly lower than 5th-generation stealth aircraft. However, its biggest drawback is that it is not a stealth aircraft. The F-1515 aerodynamic design inherently did not prioritize this factor. This means that in heavily contested airspace with modern enemy air defenses, the F-15X would have lower survivability if operating alone and would heavily rely on its EPAWSS, standoff weapons, or support and guidance from stealth aircraft like the F-22 or F-35. Personally, I think the F-15X is an extremely smart and pragmatic move by the United States Air Force. It acknowledges that not every mission requires expensive stealth capability. Instead of discarding an excellent platform, they modernized the F-15 into a heavyweight boxer capable of carrying an unmatched weapon load, serving as a bomb and missile carrier to support stealth fleets, or performing homeland air defense and air superiority missions in less contested areas. It represents a sensible balance between top-tier capability and cost, ensuring the necessary quantity and firepower for a global air force. Regarding price, the F-15X is marketed by Boeing and the USAF as a cost-effective solution. The price per F-15X unit is often cited by defense news sources to be around $80 to $90 million USD flyaway cost. The cost for the aircraft itself off the production line, not including research, spares, training. This figure is clearly significantly lower than the F-35A. The cost per flight hour is also expected to be much lower than 5th-gen aircraft, helping maintain a large fleet within a more reasonable budget. This is a key factor that led to the F-15X being chosen to replace aging F-15CD fleets. At number 8, we come to a true beast from the eastern skies, the pinnacle of the famous flanker fighter family, the Sukhoi Su-35 Flanker E. Designated by NATO as Flanker E, this is the most extensively modernized and powerful version of the legendary Su-27 lineage, classified as a 4+ generation aircraft and Russia's potent answer to Western 4.5 gen fighters, a formidable heavy fighter in both air combat and ground attack roles. The most outstanding feature that made the Su-35's name and sets it apart is its nearly unmatched supermaneuverability. Thanks to a pair of extremely powerful Saturn All-41 phones engines with multi-axis thrust vectoring control (TVC) nozzles, combined with advanced aerodynamic design, the Su-35 can perform extremely complex flight maneuvers, like the Pugachev's Cobra, high angle of attack turns, and sudden changes in direction that conventional aircraft cannot replicate. This capability provides a huge advantage in close-range air combat dogfights, allowing it to evade missiles and gain advantageous attack positions. In terms of electronics, the Su-35 is equipped with the AESA passive, electronically scanned array AESA radar, a very powerful system with a claimed detection range of up to 400 km for large targets. Although AESA, the AESA remains a formidable radar. It is supplemented by the OLS-35 infrared search and track (IRST) system, allowing passive target detection and locking without emitting radar signals, increasing the element of surprise. The cockpit is modernized with multi-function displays. The Su-35 can carry up to 8 tons of weapons on 12 hardpoints, a diverse arsenal ranging from ultra-long-range air to air missiles like the R-37M, medium range, R-77, short range, R-73 to anti-ship, anti-radiation missiles, guided bombs, and rockets. Objectively assessing, the Su-35 is an extremely powerful fighter in dogfights thanks to its super maneuverability and powerful engines. Its radar and IRST systems have long ranges, coupled with the ability to carry diverse weapons and a large payload. It is a very dangerous opponent for 4th and 4.5th generation aircraft. However, the Su-35's core weakness is its lack of true stealth capability. Although Sukhoi implemented some measures to reduce its radar cross-section, RCS, compared to older flanker versions, its RCS is still significantly larger than 5th-gen aircraft, making it much more easily detected and targeted from afar by modern AESA radars. The AESA radar, though powerful, is also considered less flexible, less resistant to jamming, and less capable of tracking multiple targets simultaneously compared to advanced AESA radars. The Su-35's actual combat performance in recent conflicts, such as in Ukraine, also suggests it remains vulnerable to modern air defense systems and electronic warfare tactics. In my personal opinion, the Su-35 represents the pinnacle of 4+ generation fighter design. It is an aerodynamic and engine power masterpiece, an aerial gladiator. If engaged within visual range, it is truly a fearsome opponent that could make any pilot wary. However, in an era where beyond visual range BVR combat and the first shot advantage provided by stealth are increasingly dominant, the lack of true stealth is a major limitation. It's like a powerful warrior wearing shining armor on a modern battlefield, easily becoming a target for hidden assassins. Regarding price, the export price of the Su-35 is often estimated by public sources to range from $50 million to $80 million USD per unit, depending on the configuration, order quantity, and specific contract terms regarding weapons, training, and spare parts. This price point can be considered competitive compared to some Western 4.5 gen fighters, but it remains a significant investment for any nation. The operating cost of a heavy twin-engine fighter like the Su-35 is certainly not insignificant either, requiring a substantial defense budget to maintain effective operations. Position number 7. belongs to the pride of the European aviation industry, a powerful multinational warrior, the Eurofighter Typhoon, a product of the ambitious collaboration between four leading industrial nations, the UK, Germany, Italy, and Spain, through corporations BAE Systems, Airbus Defence and Space, and Leonardo. The Typhoon was initially designed as a top-tier air superiority fighter to counter Warsaw Pact threats during the Cold War, but has continuously evolved and improved to become a formidable multi-role platform in the 21st century. The Typhoon stands out with its canard delta wing design, an aerodynamic configuration providing excellent maneuverability, agility, and outstanding flight performance, especially at high speeds and high altitudes. Powered by two extremely powerful Eurojet EJ200 turbofan engines, the Typhoon can reach a top speed of Mach 2 and sustain supersonic flight without afterburner supercruise under certain configurations and conditions, offering advantages in approach and disengagement speeds. The Typhoon's cockpit is a modern glass cockpit, optimized for the pilot with multifunction displays, a helmet-mounted symbology system HMSS, and notably, a direct voice input DVI system, helping reduce pilot workload. Regarding sensors, the latest versions Tranche 3 and 4 are equipped with the extremely advanced Capture E-Active, electronically scanned array AESA Radar, capable of tracking multiple targets simultaneously with high precision and good resistance to jamming. Additionally, there's the Pirate Passive Infra-Red Airborne Track Equipment, Passive Infrared Search and Track System, allowing target detection without revealing its own position. The sophisticated DAS Defensive Aid subsystem helps warn of threats and automatically or semi-automatically activate countermeasures. The Typhoon's arsenal is diverse and potent. In air combat, its trump card is the Meteor Beyond Visual Range Air-to-Air Missile, BVRAAM, one of the best active radar-guided missiles in the world today, complemented by short-range missiles like ASRAAM or IRIS-T. For ground attack missions, the Typhoon can carry Storm Shadow, Scalp EG cruise missiles, Brimstone anti-tank missiles, and various laser and GPS guided bombs like Pavway and JDAM. Objectively assessing, the Eurofighter Typhoon's strengths are its excellent flight performance, including speed, climb rate, agility, and especially its beyond visual range air combat capability when equipped with the Capture E AESA radar and Meteor missiles. Its avionics and sensor suites are increasingly modernized. Multi-role capability is also continuously being perfected through software and hardware upgrade packages. However, compared to its direct competitor, the French Dassault Rafale, the Typhoon, in its early development stages, was somewhat slower in fully integrating diverse and sophisticated ground attack capabilities. Although this gap is gradually closing, the development and production costs of this multinational cooperative program were also quite expensive and complex. And like other 4.5 generation aircraft, the Typhoon does not possess stealth capabilities. In my personal opinion, the Eurofighter Typhoon is a clear demonstration of Europe's capability in high-tech defense. The initial focus on air superiority created a platform with peak performance, a true hunter in the sky. The continuous investment by participating nations in upgrades, especially with AESA radar and new weapons like Meteor, ensures that the Typhoon remains a formidable opponent and maintains a leading position in the air forces of many countries for years to come. It might not have been designed as omni-role from the start, like the Rafale, but its effectiveness in its core role is undeniable. Regarding price, the Eurofighter Typhoon falls into the expensive heavy fighter category. The cost per aircraft flyaway cost varies significantly depending on the equipment package, purchase timing, and bilateral agreements, but estimates typically range from €90 million to €125 million, equivalent to about $100 million to $140 million USD, depending on the exchange rate. This price reflects advanced technology, powerful capabilities, and the complex costs of a large-scale international collaborative program. Operating and maintenance costs are also commensurate with a modern twin-engine fighter, requiring a substantial defense budget. Standing at number 6 is the precious gem of the French military aviation industry, a fighter aircraft famous for its flexibility, sophistication, and comprehensive combat capability, the Dassault Rafale. The name Rafale, meaning gust of wind or burst of fire in French, has truly created a powerful gust, not only within the French Air and Space Force and Navy, but also in the highly competitive global 4.5 generation fighter export market in recent years. The unique point and core design philosophy of the Rafale from its inception is its omni-role capability. Unlike many other aircraft optimized for a primary role before expanding to others, the Rafale was built to simultaneously perform different types of missions within the same sortie, from air superiority combat, deep strikes with precision weapons, visual and electronic reconnaissance, suppression destruction of enemy air defenses, seed dead, anti-ship attack, to nuclear deterrence, a specific mission for the French forces. To achieve this, the heart of the Rafale is an extremely sophisticated avionics and sensor system, intelligently integrated and fused. The latest versions are equipped with the Thales RBE, active electronically scanned array, AESA Radar, providing superior multi-target detection and tracking capabilities. A particular highlight is the Spectra Integrated Electronic Warfare Suite, a highly regarded defensive system known for its ability to detect threats, early radar, missiles, identify their location, actively jam, and effectively deploy decoys. Additionally, the OSF Optronique Secteur Frontal Electro-Optical System combines infrared and visual laser channels, allowing passive target search, tracking, and designation. All data from these sensors are fused and presented intuitively to the pilot, providing superior situational awareness. The Rafale is compatible with a very rich catalog of made in France and European weapons. In air combat, it can carry Mica missiles, infrared, or active radar homing, and the long-range Meteor missile. For ground attack, there are Scalp EG long-range cruise missiles, AASM Hammer precision-guided bombs with various guidance kits, GBU laser-guided bombs, and M39 Exocet anti-ship missiles. Naturally, it also carries the ASMP, a tactical nuclear missile for France only. The Rafale M version, for the French Navy, has a reinforced landing gear, a longer nose gear strut, and an arrestor hook for operations aboard the aircraft carrier Charles de Gaulle. Objectively assessing, the Rafale's greatest advantages are its excellent flexibility and versatility, the ability to perform multiple missions simultaneously that few aircraft in the world can match. The Spectra Electronic Warfare Suite is a standout strength, providing high survivability on the modern battlefield. It has also been proven and validated through numerous real-world operations in which France participated in Afghanistan, Libya, Mali, Iraq, and Syria. Although not a true stealth aircraft by fifth-generation standards, the Rafale incorporates certain design measures to reduce its radar cross-section, RCS. To some extent, combined with its powerful electronic warfare capabilities to compensate. Compared to some competitors of the same generation, its maximum range or payload might not be the absolute largest, but the balance, optimization for omni-role capability, and effectiveness across various mission scenarios are the Rafale's most valuable points. In my personal opinion, the Rafale embodies France's philosophy of independent defense and high technological capability. Instead of joining complex multinational projects with compromises on requirements, Dassault persistently pursued and created an extremely balanced, sophisticated, and effective aircraft tailored to its own needs. Subsequently, achieving great success in the export market. Its ability to integrate new weapons and systems relatively easily demonstrated through upgrades like 3R, F4, and the trust shown by many nations recently highlight the real appeal and capability of this gust of wind. Regarding price, the Rafale certainly belongs to the expensive fighter category. The price per aircraft depends heavily on the specific configuration BCM versions, order quantity, and accompanying packages for weapons, spares, training, and technology transfer. Recently announced export contracts suggest prices can range from around 90 million euros to over 110 million euros per unit, equivalent to about $100 to $125 million USD. Despite its high cost, its outstanding flexibility, combat-proven capabilities, and long-term upgrade potential are factors that lead many countries to invest in the Rafale. At number 5 is the greatest hope and ambition of the Russian military aviation industry in the new era, the Sukhoi Su-57, designated by NATO as Felon. The Su-57 is Russia's first and, to date, only attempt to build and field a fifth-generation fighter aircraft, designed to compete directly with formidable American rivals like the F-22 Raptor and F-35 Lightning. The second, it is a complex project that has undergone a lengthy development process with many challenges, always attracting special attention and considerable debate from global military observers. In terms of design, the Su-57 clearly intends to incorporate characteristic elements of the fifth generation, shaping to reduce radar cross-section (RCS), intakes, and engine exhausts, designed to mask thermal and radar signatures, use of composite materials and radar-absorbent coatings, and large internal weapons bays to carry missiles and bombs without increasing detectability. However, a notable difference compared to the F-22 and F-35 is that the Su-57 appears to retain the supermaneuverability philosophy characteristic of the Sukhoi school. It has an aerodynamic design optimized for agility and is expected to be equipped with new generation engines, is Del I-30 featuring 3D thrust vectoring, controlled TVC when finalized, enabling unconventional flight maneuvers. The Su-57-57's electronic systems are also ambitious. A technological highlight is the No-36 Bielka Active Electronically Scanned Array AESA Radar system. This system includes not only a main AESA array in the nose, but also auxiliary AESA arrays on the cheeks and leading edge extensions, significantly expanding the scanning angle and target detection capability around the aircraft. Additionally, there is the 101KS Atoll integrated electro-optical targeting system, including an infrared search and track IRST sensor, ultraviolet missile approach warners, and other systems. The cockpit is digital with large displays. The Su-57 has two main internal weapons bays to carry air-to-air missiles like R-77M, R-74M2, and air-to-ground munitions to maintain stealth, but also has external hardpoints for carrying larger payloads or oversized weapons when needed. Objectively assessing, the Su-57 is an ambitious fifth-generation fighter design on paper, attempting to blend stealth, supermaneuverability, and advanced electronics. The multi-array AESA radar system and IRST are potential strengths if they function effectively. However, to date, many questions and controversies surround the Su-57-57's actual capabilities. Its level of stealth, particularly in early versions, still using the interim Al-41 phone engines, an improved version of the Su-35 engine with non-optimized nozzles, is considered by many Western experts to be significantly inferior to the F-22 or F-35. The development and mass production of the new generation is Del I-30 engine, a key factor for the Su-57 to achieve its design performance, including supercruise and better stealth. have faced numerous delays and challenges. Most importantly, the number of Su-57 aircraft actually produced and inducted into service with the Russian Air Force remains very limited, only a few dozen, making the fleet size and actual strategic impact negligible so far. Its effectiveness and reliability in high-intensity combat operations have also not been clearly and independently verified. In my personal opinion, the Su-57 is like an interesting but also dubious unknown variable in the military aviation technology race. It shows Russia's great effort and determination to possess fifth-generation fighter capabilities. The approach of combining stealth, even if perhaps not as optimized as rivals and supermaneuverability, is unique and could offer advantages in certain situations. However, the challenges with core technology's engine, materials, stealth integration maturity, and especially the ability to mass produce in large numbers, at reasonable costs, and with consistent quality, seem to remain enormous hurdles for Russia in the current context. The future and true status of the Su-57 on the global air power chessboard will likely only become clearer in the coming years, when and if it is equipped with the complete ISDIL-30 engine and produced in sufficient numbers. Talking about the price of the Su-57 is extremely difficult due to the program secrecy, low production numbers, and lack of successful export contracts. Russian officials previously quoted very attractive figures, claiming export prices could be around $50 million USD per unit, much lower than the F-35, to attract potential customers like India, although India later withdrew from the joint development program. However, this price is widely doubted by international analysts as unrealistic for such a complex fifth-generation fighter, or perhaps only representing the basic airframe cost without the expensive accompanying packages for weapons, training, logistics, and technical support. The enormous research and development costs of the Su-57 program undoubtedly make the actual production cost substantial. Entering position number 4, we welcome a rising star, a name representing the future of U.S. strategic air power and perhaps the most advanced bomber project currently underway in the world, the Northrop Grumman B-21 Raider. Although it only officially made its first flight in November 2023 and is currently in the engineering and manufacturing development (EMD) testing phase, preparing for low-rate initial production (LRIP), the B-21 has already generated immense anticipation and significantly influenced the global military balance of power. The B-21 Raider was conceived from the Long-Range Strike Bomber LRSB program, aiming to create a successor to both the B-1 Lancer and its elder brother, the B-2 Spirit. It inherits the iconic flying wing design philosophy of the B-2, but is developed with the latest generation stealth technology, incorporating breakthroughs in materials, surface coating techniques, and computational modeling. The ultimate goal is to create an aircraft with extremely high survivability, capable of penetrating deep into areas protected by the most advanced integrated air defense systems (IADS) for decades to come, a task increasingly difficult for older generation aircraft. A revolutionary difference compared to the B-2 is that the B-21 was designed from the outset with open systems architecture, robust networking capabilities, and multi-functional sensor integration. This allows it to be not just a weapons delivery platform, but also potentially function as an intelligence, surveillance, reconnaissance, ISR gathering node, and even an airborne command and control center in the complex future multi-domain battle environment. Joint All-Domain Command and Control, JADSAT-2. Notably, the B-21 is designed with the technical foundation to allow for optional unmanned operation in future missions, opening up entirely new operational possibilities. Regarding its core capability, the B-21 will carry both conventional and the latest generation nuclear weapons in its internal bay. It is capable of precision strikes from standoff ranges or directly attacking hardened, high-value targets deep within enemy territory. Intercontinental range is a mandatory requirement, ensuring the United States' global reach and power projection capability. The B-21's engines are optimized for efficiency, reliability, and minimized signatures. Objectively assessing, the B-21 Raider promises a leap forward in stealth strategic strike capability, surpassing even the B-2. Its networking capability and function as a multi-role sensor command node will make it an extremely valuable and flexible asset on the modern battlefield. The focus by the USAF and Northrop Grumman on applying advanced digital design and manufacturing methods to control costs and improve maintainability is also a major plus, aiming for a fleet of at least 100 aircraft, a much larger number than the B-2. However, this remains an extremely complex program with enormous costs and potential technical challenges during testing and transition to full-scale production. All detailed specifications regarding its performance, actual stealth level, and specific features are classified at the highest level. In my personal opinion, the B-21 is not just a replacement for older bombers. It completely redefines the role and capability of the strategic bomber in the 20th century. It's not just a bomb carrier, but a flying brain, an indispensable link in the information-centric warfare network. The combination of next-generation stealth, deep networking capabilities, and the unmanned option makes the B-21 a revolutionary weapon, a fearsome strategic deterrent, and the core foundation for America's long-range air power for many decades to come. Regarding price, this is a point of particular interest. The United States Air Force set an average procurement unit cost APUC target of about $550 million in 2010 dollars. Adjusted for inflation and current value, around 2024-2025, this figure equates to roughly $750 million USD. While still an enormous sum, it is significantly lower than the unit cost of the B-2 estimated at over $2 billion, including R&D. Maintaining this target price throughout full-scale production, planned for at least 100 aircraft, will be a major challenge for the Pentagon and Northrop Grumman. But if successful, it will allow the U.S. to possess a next-generation stealth bomber fleet in sufficient numbers and with more reasonable life cycle costs, something they couldn't achieve with the B-2. And here's the top 3. At position number 3, we have a mighty dragon from the east, a symbol of the rapid rise and technological ambition of China's military aviation, the Chengdu J-20 Mighty Dragon Wei Long. As the first 5th-generation stealth fighter, independently designed, developed, and mass-produced by China, the emergence and increasing numbers of the J-20 have profoundly changed the air power landscape in the Asia-Pacific region and posed new strategic challenges globally. The J-20 possesses a very distinctive aerodynamic design, different from its American or Russian counterparts. It features a long fuselage, a chiseled nose section for stealth, large delta wings combined with fairly large canards up front, along with diverterless supersonic inlets, DSI, and 2 powerful engines. This configuration is believed to balance stealth capability, especially from the frontal aspect, supersonic performance, and the agility needed for air combat. Large weapon bays are located internally within the fuselage, and on the sides to minimize radar cross-section, RCS. Although the J-20's aspect stealth level, compared to the F-22 or F-35, is still debated among international analysts, it undeniably represents a huge leap in stealth technology compared to previous generations of Chinese fighter aircraft. Inside the J-20 lies a suite of advanced avionics. Central to this is the indigenous active electronically scanned array, AESA Radar, believed to be type 1475 or KLJ-5, providing long-range multi-target detection and tracking capabilities. Under the nose is an electro-optical targeting system, EOTs integrating infrared and laser sensors, similar to the F-35's, allowing passive search, track, and designation of air or ground targets. There are strong indications that the J-20 is also equipped with a distributed aperture electro-optical system, similar to the F-35 DAS concept, providing the pilot with 360-degree situational awareness and early warning of threats like incoming missiles. A modern glass cockpit with large multifunction displays and an integrated electronic warfare suite are standard features. Regarding performance and weapons, the J-20 is designed for high-speed Mach 2+ and long range, suitable for operations over the vast expanses of the Asia-Pacific region. Engine development has been a notable point. Initial production batches used Russian Al-31F engines, later transitioning to improved domestic WS-10C Taihang engines with more thrust and full authority digital engine control (FADEC). However, the ultimate target engine for the J-20 is the WS-15 AESA, designed to provide significantly more thrust and supercruise capability. The development status and mass production of the WS-15 remain somewhat uncertain, although recent reports suggest it has begun to be installed on newer J-20 batches. The J-20's primary air-to-air armament consists of the PL-15 long-range active radar homing missile, carried in the side weapon bays. It also carries the PL-10 high agility, short-range infrared homing missile. The large ventral weapon bay can carry additional PL-15 missiles or potentially air-to-ground munitions in the future as the J-20's role expands. Objectively assessing, the J-20 is clearly an outstanding defense technology achievement and a source of pride for China. It integrates most core technologies of a fifth-generation fighter, such as stealth design, AESA Radar, EOT, and internal weapon bays. Its long range and ability to carry modern long-range air-to-air missiles like the PL-15 are significant tactical advantages. The number of J-20s entering service is increasing rapidly, showcasing China's priority and defense industrial capacity. However, unresolved questions remain regarding its true all-aspect stealth level, especially from the sides and rear, the reliability and actual performance of its complex electronic systems in high-intensity combat environments, and most importantly, the maturity, mass production status, and performance of the WS-15 engine, the key factor for the J-20 to truly reach its full design potential, especially supercruise capability. In my personal opinion, the J-20 is more than just a fighter aircraft. It's a powerful statement about China's ambition to become a leading military power and its increasingly formidable technological capabilities. The speed of the J-20's development and induction into service is truly astonishing, demonstrating their ability to learn, absorb technology, and invest enormous resources. While there may still be areas needing refinement compared directly to the F-22, the J-20 has undoubtedly become a strategic game-changer in the Asia-Pacific, forcing nations within and outside the region to seriously reassess and formulate countermeasures. Talking about the price of the J-20 is extremely difficult, as China maintains strict secrecy regarding defense spending details, especially for strategic weapons programs. No official figures have ever been released concerning the research, development, or production costs of the J-20. Western analysts and intelligence agencies can only offer estimates based on comparisons with other fifth-generation aircraft programs, production scale, and indirect economic data. These estimates often vary widely, but commonly range from $100 million to $120 million USD per aircraft. However, these are merely speculations. What is certain is that China is investing enormous financial and industrial resources to produce the J-20 in increasingly large numbers, indicating their willingness to accept high costs to rapidly acquire and enhance this strategic capability. Only two names remain in the runner-up position. Number 2 is an aircraft that has redefined the concept of the multi-role fighter in the 20th century. One of history's largest, most ambitious, and perhaps most complex weapons programs, the Lockheed Martin F-35 Lightning II. Developed from the ambitious U.S. Joint Strike Fighter (JSF) program, the F-35 was conceived with the goal of becoming a single solution, or nearly single solution, to replace a wide range of legacy fighter aircraft for the U.S. Air Force, Navy, and Marine Corps, as well as close allies, with three main variants: F-35A conventional takeoff and landing, CTOL, F-35B, short takeoff and vertical landing, STOVL, and F-35C carrier variant, CV-1, and having been chosen by dozens of countries worldwide. The F-35 is and will be the primary backbone of Western tactical air power for decades to come. The F-35 was designed from the ground up with a primary emphasis on very low observability, VLO, against modern radar systems, enabling it to penetrate and operate effectively in dense enemy air defense environments. But what truly sets the F-35 apart and gives it exceptional power, earning it nicknames like flying computer or quarterback in the sky, is its unprecedented ability to fuse information from a network of advanced sensors. The powerful and APG-81 AESA Radar, the AAQ-37 Distributed Aperture System DAS, with 6 infrared cameras providing 360-degree coverage, allowing the pilot to see through the airframe and providing missile warning. The AAQ-40 Electro-Optical Targeting System, EOTs integrating IRST and laser capabilities, and the highly sophisticated and ASQ-239 Barracuda Integrated Electronic Warfare Suite. All are connected and processed by a powerful central computer. Data from all sources is fused into a single, intuitive, and easily understandable battlefield picture, presented to the pilot via a large panoramic cockpit display, and, notably, through the next-generation helmet-mounted display system, HMDS. The F-35 not only sees and hears extremely well itself, but it also seamlessly shares that data with other F-35s, 4th-gen aircraft, ground command centers, and warships via secure data links like MADL and Link 16, creating superior cooperative engagement capabilities. Regarding weapons, to maintain stealth, the F-35 carries weapons in 2 internal bays, typically 2 AMRAAM air-to-air missiles, and 2 precision-guided bombs like JDAM or SDB. The F-35A variant has an internal GA-22 A25 Menon cannon, while the F-35B and C use an external gun pod if required. When missions do not demand maximum stealth or require heavier firepower, the F-35 can utilize external wing pylons beast mode to carry many more missiles and bombs, significantly increasing its payload. Objectively assessing, the F-35's undeniable strengths lie in its combination of leading stealth capability, superior sensor fusion and information processing, and cutting-edge network-centric warfare capabilities. This provides F-35 pilots with situational awareness and rapid decision-making advantages unmatched by any other aircraft. Its true multi-role nature, ability to effectively replace multiple older aircraft types, and widespread adoption among allied air forces, enhancing interoperability, are huge strategic advantages. However, the F-35 program also faced heavy criticism, especially regarding its initially exorbitant development and procurement costs compared to projections, significant delays, and numerous complex technical issues that needed fixing in the early stages. Although the F-35's maneuverability has been significantly improved through software upgrades, it was not designed to be a dogfight king like the F-22. The cost of operating and sustaining the F-35 over its life cycle cost per flight hour remains substantial, and is a focus for the Pentagon and partner nations. In my personal opinion, the F-35 is the clearest evidence that modern air warfare is no longer just a race for speed or mechanical agility, but a battle of information, data processing, and network connectivity. It might not be the prettiest or most acrobatic aircraft, but its ability to see first, understand first, shoot first, and coordinate other forces on the battlefield makes it a true game changer, a core element of 20th century air power. The intense initial controversies over cost and capability seem to be gradually subsiding as the F-35 increasingly proves its worth in exercises and real-world operations, and as production costs have significantly decreased due to large-scale manufacturing. For me, the F-35 represents the present and future of the multi-role fighter concept. Talking about price, this has been a bright spot for the F-35 in recent years. After initial cost criticisms, thanks to efforts by Lockheed Martin and increasing production scale, the cost per F-35 has dropped significantly. Currently, as of early 2025, the unit flyaway cost for the F-35A variant, the most common and least expensive, has stabilized below the $80 million USD threshold for the latest production lots from LRIP 15 onwards. The F-35B, with its complex double lift system, and F-35C, with larger wings and reinforced landing gear for carrier operations, are more expensive, typically over $100 million USD. Although the purchase price has become more competitive, the cost to operate and sustain the F-35 throughout its lifecycle cost per flight hour, maintenance, upgrades remains a large figure, and continued efforts to reduce these costs are a major goal of the program. And finally, the champion position, the aircraft hailed as the absolute pinnacle of fighter technology, the undisputed king of air combat capability for nearly 2 decades, the Lockheed Martin F-22 Raptor. As the world's first operational 5th-generation stealth fighter, the F-22 Raptor was designed by the United States Air Force with a single, ultimate objective: to establish and maintain complete air dominance, clearing the skies of any current or projected adversary threat to ensure freedom of action for other friendly forces. The F-22's fearsome power comes from the near-perfect combination of the 3 core elements that define a true 5th-generation fighter: stealth, supercruise, and supermaneuverability. Stealth technology is deeply integrated into every aspect of the airframe design, from the serrated edges, canted surfaces, special inlets, and heat signature masking engine nozzles, to advanced radar-absorbent material coatings. All weapons are carried in enclosed internal bays, making the F-22 nearly invisible to most enemy radar and sensor systems. The ability to sustain supersonic flight at Mach 1.8 or higher without using fuel-guzzling afterburners, supercruise, allows the F-22 to rapidly approach targets, engage and disengage, gaining advantages in energy and reaction time. And finally, its pair of extremely powerful Pratt & Whitney Phone 119 engines with 2-dimensional pitch axis thrust vectoring nozzles, combined with a superior aerodynamic design, grants the F-22 extraordinary maneuverability, capable of performing turns and directional changes that defy physics and overwhelm opponents in close-range air combat. The F-22's integrated avionics suite was also a technological marvel at the time of its introduction. It's an APG-77, active electronically scanned array, AESA Radar, can detect and track multiple targets at very long ranges with a low probability of intercept LPI. Notably, it's an ALR-94 electronic warfare system functions as an extremely sensitive passive radar warning receiver, capable of detecting and precisely locating enemy emitters from hundreds of kilometers away without the F-22 needing to turn on its own radar, providing unparalleled situational awareness while remaining silent. The F-22's primary air-to-air armament consists of 6 AIM-120 AMRAAM medium to long-range missiles carried in the main ventral bay, and 2 AIM-9 Sidewinder short-range heat-seeking missiles inside bays. It also possesses a secondary ground attack capability, able to carry 2 1,000-pound JDAM guided bombs, or 8 small-diameter bombs, internally in place of some AMRAAMs. Objectively assessing the F-22 Raptor, in terms of pure air-to-air combat capability, is still considered by most to be unrivaled. The synergy of its top-tier stealth, exceptional speed, high operating altitude, incredible agility, and powerful sensor systems creates an overwhelming advantage against any other fighter aircraft in the world today, including other fifth-generation aircraft in certain scenarios. It was specifically designed for the air superiority mission and performs that role flawlessly. However, the F-22's greatest and most regrettable weakness is its extremely high production and operating cost. This led to the controversial decision by the US government to halt the production line in 2011, capping the total operational fleet at only 187 aircraft. This small number significantly limits the ability to deploy the F-22 simultaneously across multiple theaters and restricts its large-scale strategic impact. Compared to the F-35, its networking and data-sharing capabilities were not designed as extensively, and upgrading its complex systems is also very costly. Furthermore, US federal law strictly prohibits the export of the F-22 to any nation, even the closest allies. In my personal opinion, the F-22 Raptor is an aerospace technology masterpiece, a true monster dominating the skies. It represents the absolute pinnacle of human achievement in air superiority fighter design. Despite its small numbers and ceased production, each F-22 remains a priceless strategic asset, a symbol of power, and an undeniable deterrent for the United States Air Force. The decision to stop its production is, in my view, perhaps one of the most short-sighted and regrettable decisions in modern defense procurement history. It feels like humanity forged the legendary sword, Excalibur, with unparalleled power, only to decide to lock it away after making fewer than 200. Talking about the price of the F-22 today is almost meaningless, as it's no longer in production and was never allowed to be sold internationally. However, to provide context for its expense, the total program cost for the F-22, including research, development, and the production of 195 aircraft, including test models, is estimated at around $67 billion USD. The unit production cost flyaway cost for the final aircraft off the line was about $150 million in 2009 dollars. But if the massive R&D costs are averaged over the small number of aircraft produced, the actual cost attributed to each F-22 amounts to over $350 million USD, a staggering figure. The cost per flight hour for the F-22 is also among the most expensive in the world, requiring an enormous budget for maintenance and sustainment. So, we have completed our impressive journey together, exploring the top 10 military aircraft considered the most powerful and formidable in the world today. From the stealthy strategic bomber ghosts like the B-2 Spirit and its promising successor, the B-21 Raider, to the ultimate air combat killers combining stealth, speed, and agility like the F-22 Raptor, or the comprehensive multi-role flying brains like the F-35, Lightning II, and Dassault Rafale. Every name on this list, whether it's the rapidly rising J-20 Mighty Dragon, the potent Eurofighter Typhoon and Su-35 Flanker E, or the missile truck 15X, Eagle II, is a testament to the pinnacle of science and engineering, defense industrial might, and the complex geopolitical, strategic calculations of the nations that possess them. Of course, as we mentioned, any ranking is relative, and based on specific criteria and perspectives. Assessing the most powerful is extremely complex, because the true power of an aircraft depends not only on its technical specifications on paper, but also on many other factors. The skill and experience of the pilot, the tactics employed, the effectiveness of logistics and maintenance systems, the ability to operate cooperatively with other forces, and especially the specific context in which it is deployed. Perhaps you have your own top 10 list with different priorities and assessments, and that is perfectly understandable and interesting. But it cannot be denied that the 10 machines we just explored represent the finest, most complex, most powerful, and also most expensive creations currently flying in our planet's skies. They are the tools that shape the military balance of power, strategic deterrence, and factors that can profoundly impact the future course of the world. We sincerely thank you for patiently following and accompanying us throughout this journey, exploring the top 10 most powerful military aircraft. Hopefully, through the analysis and insights shared, you have gained interesting information, diverse perspectives, and felt some of the wonder and complexity of cutting-edge military aviation technology. If you found this content useful, engaging, and wish to support us, please don't hesitate to hit the like button and share this article video with your friends, family, and anyone who shares a passion for military affairs and technology. And most importantly, if you haven't subscribed yet, please hit the subscribe button and the notification bell next to it so you don't miss any new content, in-depth analyses, and other fascinating stories we will bring you in the future. We look forward to receiving your feedback, comments, and even your own rankings in the section below. Let us know what you think and what topics you'd like us to explore next. Once again, thank you sincerely for your interest and support. Goodbye, and see you again soon.